Hello, everyone. My name is Iosif Itkin. I'm CEO and co-founder of Exactpro. I hope recording of this webinar will appear on Exactpro YouTube channel, where we do have many interesting materials dedicated to software testing, to complex systems, to AI, software development, etc. I'm proud of many videos that are present there, and one of them in particular is dedicated to the concept present in ISTQB AI testing course called AI effect. AI effect is stands for a common situation where perception of what is considered to be AI technology and what is not considered to be AI technology changes over time. So like 40 years ago, if you ask somebody, is playing chess is AI? So ability to play chess, whether it requires intelligence, everyone would say yes, of course. In order to be good at chess, you have to be a very intelligent person. But now, if we will ask about chess, the common perception is that it is just reinforcement learning. So nothing related to real intelligence. And the same thing happens with any other area of any other type of tasks. As soon as software is able to perform particular task, this task is no longer considered to be intelligent or AI. So this is AI effect. Recently, I've encountered a funny definition of what is AI effect. So AI is software, and if this software works reliably, then it is just software. If there are problems and we do not understand how the software works, it is AI. So the more reliable particular system gets, the less intelligent it is considered to be. Overall, it would be fair to say that lots of tasks from translation to image recognition and everything else are now considered to be delivered by AI technologies. Even some of the coding tasks can be supported by AI technologies. And many people think that introduction of them into your day-to-day life results in productivity increase. I think I've observed it myself. So some of the coding tasks and some of the writing tasks are so much faster using these new exciting technologies. But there is a term called productivity paradox. Have anyone ever heard about productivity paradox? I've discovered it only recently from a blog post of one of our colleagues on the subject. So productivity paradox stands for the fact that it is clear that there are productivity gains on individual level. But for some reason, they do not appear in productivity statistics for companies, countries, etc. So it looks like AI is everywhere, apart from productivity statistics on a global scale or even on individual organizations scale. And this observation is called AI productivity paradox. I recommend to have a look at the blog post on the subject. It appeared recently, but in fact, people think about it for some time, and they try to compare this particular event to previous cases of introducing generalized technologies like telecommunications, semiconductors, computers, etc. So for quite some time, the increase in productivity is not observable in economics data. And so people were thinking about it, well, 30 years ago about computers, and the last few years on the subject of AI. So image recognition went into exceeding human level almost a decade ago. But there is no huge spike in productivity caused by AI technology. It is not visible in global economics data. So there are papers about it from 2024, 2025, 2017. So it is not yet observable. And one of the reasons for that is that some of AI technologies that are available at the moment, they are easy for individuals. So adoption and using some of these technologies is frictionless. And in many cases, it is even possible to use a lot of them for free. One of the things when ChatGPT appeared, Elon Musk said that AI technologies were there for many years before that, but there was no user interface. And with ChatGPT, user interface appeared and became available for individuals to interact with it. And it is very easy for most of us to do something with it. It can support our creativity and flexibility. We can check grammar, we can request particular blocks of code, and it is easy to use it on a personal level if we are not trying to generalize it. And even hallucinations that are present there, they are less risky on a personal scale, because if in 2025 you think that chatbot will never lie to you, then it is something is wrong with you. So you can just accept that not everything that appears on the screen is necessarily true or exist in reality. So humans can go and check. It is easier to work with this set of technologies as individuals because most of the time there is not a single intelligence involved. So in addition to whatever technology is providing responses, we also have human intelligence near the same screen. And most of the time, when somebody is trying to use it for anything, they are present and they do use their own intelligence and their own brain. So we obtain productivity gains from using generative AI because our own intelligence is also present to quickly evaluate the output. So it is very easy to use for one. Situation is completely different when we are trying to use it not at the scale of one, but we are trying to use the power of many. So organizations exist to optimize effort. But when we are trying to use the same kind of technology on organization level, there are immediate security and compliance concerns with the data, with all types of data, with IP, with integration, with internal, external systems. Most of the time, the return of investment models are not clear. And internal communication on using these types of technology is also difficult. So this is a recognized fact across many industries. So this is a slide from AI testing course. There are lots of problems with the data. And when you try to use it in organizations, it immediately becomes a problem. Most organizations, so I think I haven't seen yet one that is not aware that there are lots of embarrassing cases where something goes wrong with technology. So there are databases exist and list of the problems exist that describe bad things that previously happened, and people constantly look into it and try to reflect what if the following thing will also happen in our organization. So such databases are insightful reading, but they also help to create perception that this kind of software is not yet reliable and dangerous to be used in organizations. Industry bodies, Bank of International Settlement, and others also looking at it and see the same things. So despite high expectations, current use cases in most sectors are more limited to chatbots, to some communication, to some research. Another classification that I saw recently is that the current technology is good at perception. It is not good at judgment, and it is very bad at making predictions, because it is very difficult to make predictions, especially about the future. So the use is still limited. Technology still requires to be more mature. But everyone is afraid of missing out. So there is a term, fear of missing out. And quite a lot of organizations either have mandate or would like to explore data-driven technologies and approaches. They would like to build teams and governance structures within their organizations and try to work around the productivity paradox to see some positive results, not just individual employees, but in the organization bottom line. There are many things that organizations have to consider. This one is against from this report, and you can see that 4 main pillars defined here. From them, 3 are related to data, 2 are related to platforms. I would argue a few of them are related to processes, and one important one is advancing user literacy. So building AI expertise through knowledge sharing and talent strategies. So these pillars are identified for central banks, but of course it is applicable to any important organization. In Exactpro, we use a closed model developed by Zero Outage Industry Standard that consists of 4 pillars. These 4 pillars are platforms, processes, people, and of course, underlying and foundation of everything is security. JP Morgan Chase just released a letter to all vendors emphasizing security as the main consideration for any deployment of new technology. So how can organizations adopt or try to adapt AI? The idea is to try to build a strong foundation and AI-ready environment even before you have AI systems everywhere. Be prepared to start small, but plan in advance and also set up governance frameworks earlier. Think about ethics, testing, security, compliance. Platforms is one of the important components because they are software and AI is software, but it is a good idea to keep in mind that holistic approach requires to think about all 4 pillars. In Exactpro, we work with very complex software for the last 15 years globally. We work with top global exchange groups in all continents, probably except Antarctica. And we constantly look for ideas and collaboration in the area of identifying recommended industry practices in the area of our expertise. One industry practice that we probably biased, we believe is important is software testing. Warren Buffett said, and I'm quoting it quite frequently, never invest in business you cannot understand. So if you are not able to understand something, then it is better not to invest in it. And the process of understanding software has a name, and this name is software testing. Software testing is an information service. Its goal is to provide stakeholders with information about the defects present in the software. Software testing can never confirm the absence of defects, but software testing can identify their presence. And this information is important. Building operating software without thorough testing is like devising a military operation without proper intelligence, or trying to treat patients without accurate diagnostics, or participating in electronic trading without access to market data. Information is a very important commodity, and having to have ability to extract information about your software is very important and useful. So we think that one of important avenues of AI adoption is building ability to consistently explore the software in order to find defects. We do it for many platforms, and in particular for exchanges. Exchanges have a nice feature that when exchange is down, it is visible for most of the world. And that's why it helps to build culture of trying to identify defects before the system is deployed into the live service. Also, modern exchanges in liquid markets operate with huge volumes of data. And that's why, in order to properly evaluate exchange, it is necessary to build and deploy tools and processes suitable for maintaining large data sets. There are also other features that are very specific, particular for exchanges. For example, exchanges are centralized and there are no canary deployments. It means that you are not able to deploy something on 1% of the servers and use it as a A/B test. Most of the time you have obligation to make your software available to everyone. It also leads to the fact that exchanges usually go through very substantial transformations, because when you change something, it immediately affects everyone. Regulation for exchanges is mostly principle and outcome based, similar to what we will see now in AI domain. And this type of systems is different in a sense that you always have to balance between cost and risk. So if you just have some web startup, you have more flexibility. If you work in heavily in the industry that is related to life and safety, then people usually can accept long development cycles. If you work in big tech, you can do canary deployments. You can use scale to compensate for software failures. But if you work with the system like Exchange, you are in between all these different options. So you can benefit from flexibility, from scalability, and people expect resilience without applying the same amount of time and effort that are accepted in healthcare or transportation. Sorry. So we've worked with such systems for quite some time, and we have to find ways of finding optimal strategies to work with such systems. And the funny thing is that there are many aspects of large-scale exchanges that make them similar to self-learning systems. Distributed platforms are always non-deterministic. When you have many gateways and low latency environment, you're never able to predict how messages will be routed inside the large platform. So that's why for years, we had to develop methods that are targeted specifically at probabilistic and non-deterministic nature of such systems. ISTQB AI testing syllabus define the following challenges for testing self-learning systems. Complex acceptance criteria, insufficient testing time, resource requirements, insufficient specification of operational environments, complex test environments, bias of data inputs, undesirable behavior modifications, etc. It appears that in our day-to-day life, we constantly encounter exactly the same problems. My take is that these challenges, they are inherent not to self-learning systems, but rather to every system that is sufficiently complex and distributed. The fact that people often underestimate these challenges for traditional software just reflects that people do not sufficiently understand the legacy platforms. In Exactpro, we do work with such systems for quite some time. So we have to develop test strategy that will assume that the system is having probabilistic and non-deterministic nature. And also, if you take a huge platform that, say, has 40 inbound, outbound interfaces and transactions going back and forward, and then if you try to create any sufficiently thorough test library, you'll discover that it is very difficult for individual human to understand the nature of such test library. So you can create fake simulators of this library. So you can say, okay, I have these 100 scenarios that are very important for me, and I understand these 100 scenarios. But in reality, a real complex system, it is not possible to detect enough defects by having a limited and humanly perceptible number of scenarios and paths. So everyone who is working with complex software, they have to deal with questions of transparency, explainability, and interpretability. Everyone who is involved in so-called test automation also need to understand what is autonomy and what is human intervention. So in developing ways and methods how to deal with it, we are trying to reflect all these concepts in our training and internal practice materials. And we put these materials as a part of our ISTQB course. I'll get back to it later. So how can one start trying to build something in your organization in relation to AI testing? Once again, we go through the pillars. The main pillar is security. It is foundation under everything. So if you not consider it, there is no need to talk about anything else. So the remaining three pillars are platforms, processes, and people. So on the platforms, the idea is to start with particular time-boxed proof of concept investigation of any software that uses AI technology. It might not necessarily be generative AI. Anything that is based on enough data processing and anything that has complex nature will serve as a perfect playground for you to explore how to work with such systems. So the idea is to see if you have any systems already, or are you considering any pilot projects to deploy them and involve the team to test it. So in God we trust, the rest we test. So the approach to platforms is just test them And in process, you will see gaps and problems with testing such software. Trying to understand these problems and trying to lay the foundation forward. The next pillar is processes. So processes is one of the first processes, and deciding on the testing practices. So how to work with such systems, how to build a structured testing frameworks. It is a difficult challenge. It requires imagination, human intelligence to build a platform, to build a test strategy and describe test practices that will be taken into account the inherent complexity and limitations of working in such environments, ranging from simple questions like if you need to produce lots of requests to external cloud, it can result in very substantial cost, but without having lots of scenarios, most of the time you are not able to have a sufficient test coverage. So test strategy is always finding the balance of what to do and what not to do. And of course, the last pillar, the last but not the least, is people and building collaboration between teams, groups related to building practice and educating the teams through both workshops, discussions, trainings, and practice. Yes. So, a timely reminder, 4 main pillars that one has to consider when trying to work with something that requires responsibility, I would say. On the platforms, we do look at different types of platforms, ranging from trading and clearing platforms to RAG-based implementations that are used to provide some information or organize knowledge. And if one is trying to build the to test such software, they have to think about many things, but on a practical platform level, they have to design data approach, how to generate inbound data, how to process it, how to organize efficient execution, efficient and cost-efficient execution. So as soon as we have to use lots of hardware, we always have to think about cost implications. How to collect data, where to store this data for processing, and how to interpret collected data. So if you are using data-intensive platform, most of the time it is not possible. Well, so it is possible to hit a number of defects by using local props, local requests, But in order to obtain a more structured view of what can possibly go wrong with the system, most of the time you will have to collect lots of output data and then interpret it. So the process of interpretation is where we take the data that is available and trying to make sense of this data. The last step dealing with the platforms is that no testing happens in a single iteration. So we do something, we carry out our experiments, and then we learn from them. So there is no such thing as non-reactive test strategy. Any product approach means that we do have to learn from our exploration. So we need to obtain data, we need to interpret it, and then we need to use the output of our interpretation to design consequent scenarios for complex systems. Why it is a good idea to have some pilot test engagement? First of all, is because it can give practical hands-on exposure to technology and to the challenges. And also by doing something small, you can get immediate feedback. On the other hand, if the system depends on lots of data, then you have to deal with not something small, but with something large. Pilot test engagements, internal, external, allow to perform knowledge transfer and upskilling. And also any sound recovery practice is based on practice. So, and every team has to reinvent bicycles for themselves. There is no platform and no technology that will remain unchanged within the next few months or year, well, months, definitely years. So it is not possible to do something using already available tool. Instead, organization has to constantly evaluate how to react to the changes in technology. And the best method of reacting to changes in technology is to have a well-developed team. So here we see several ways of doing it. It is individual learning, it is collaboration, and most important is practice. So whatever you learn, immediately try to put into practice as individual, as a group. Yes. On test strategy, it is important that strategy is a mixture of policy and action designed to take on some high stakes challenge. And the AI adoption is, of course, a high stake challenge. It can bring some benefits to your organization. It can also result in some negative effects. So it is important to think about what is good strategy and what is bad strategy. As a reminder, bad strategy is anything that based on the following things. On using words of no consequences. In the AI area, it is, of course, AI and agents and many other words that in many contexts might have no consequences. It is failure to face the challenge. So often organizations, when they are trying to do something, they do not really understand what is the real challenge. It is mistaken goals for strategy. So replacing all employees with AI is more like a goal and not a strategy. Or say decreasing cost, increasing revenue. These are very good goals, but they are not a strategy. And of course, bad strategic objectives. So it is often possible to select proximate targets that do not necessarily be beneficial for the organization. But whether they will be beneficial or not, it is context dependent. There was an announcement that Spotify said that there are no hiring unless you can prove that particular task can be performed by AI. One can argue whether it is a bad strategic objective or a good strategic objective. We'll see. For doing things like that, of course, challenges, actions, and deliverables are the same for ordinary systems and for AI systems. So in every large-scale complex system, there is always insufficient test coverage. So find any system that is complex, and find any test library, you will see that there is insufficient test coverage. Also, as soon as you are not able to put something into 100 lines in Excel, in 100 rows in Excel, you immediately have lack of system transparency. So humans have limited processing capacity. So as soon as we encounter something complex, we will absolutely face transparency issues. As I've already mentioned, technology changes rapidly. So if you will find any tool that is like for evaluating RAG systems, very soon it will be outdated from several different angles. So it is not that you need to find any ideal tool, any ideal LLM or any ideal anything, but rather to build foundation to be able to use them, find new one, and replace something with something. And of course, challenge is ideas overload. So there are so many possibilities and so little time. But the same challenge is present in every complex environment. What the management teams have to do, they need to be aware of it and act accordingly. But what can possibly go wrong when somebody is trying to build AI testing center of excellence. First of all, it can be considered as a theoretical exercise. And the best way to work around it is, of course, apply everything in practice. So not think about how to test AI, but test AI-enabled systems. There is lack of standardization in the field to put AI test in practice in a single group and use it as standards and guidance. It is true, but it is reality that we have to deal with. There is no standard tool, there is no standard benchmark, and we have to acknowledge that they will constantly change. So it is necessary to build a fluid approach that will be able to constantly readapt. Of course, trying to do something requires time and money, and it is often not easier to measure if something beneficial or not. For software testing, measurement is also not easy, but three main metrics that everyone should consider when thinking about any initiative in software testing is ability to detect defects, describe them, speed, and cost. So the less money you spend and the faster you do something, the better. Okay, so in Exactpro, we have a training program. We also work with our clients, and we offer services related both on using machine learning to support software testing, and also services of taking existing AI-based or AI-enabled systems and finding that are important to their stakeholders. If you ever want to learn more how to do it, please do subscribe to our social networks, try our workshops, and also, of course, explore available chapters of ISTQB AI testing course. Thank you very much. Probably that's all for me. Thank you.
Thank you, Iosif. I think we're a little bit out of time. If there are any questions, yeah, I see that someone already are dropping off, but let's read questions, a few of those.
Yeah.
Like question, first of the question, what do I need to do to start POC with AI-enabled toolset? Are there any requirements for that?
To start doing something with something, you need two things. You need something and something. So in order to start using AI to do something, you need to find some AI and start doing something with it. So in order to start testing AI-enabled systems, you need to find AI-enabled system and start testing it. In order to start using AI to test something, the first thing you need to find is data. So machine learning does not work without data. It is only a question of where this data comes from. So of course it can come from the internet, but most of the time when you're trying to use machine learning methods to support your software testing, the first question that you have to ask yourself is, where can I get a lot of diverse data? If the only data that you can get is the output of 100 scenarios, then it is not enough to get any data-based insights from this data. So every time you try to do something like that, think, how can we produce lots and lots of diverse, non-biased data from our systems? And most of the time, it is possible if you have fast and efficient ways of interacting with your software, APIs, etc. So what you need to do, you need to first configure hands, so ability to manipulate the system. Then you need to configure eyes. It is ability to look at the system and store all observations. Once you have hands and eyes, you start exploring the system's behavior by trying to go through as many permutations, interesting permutations as possible and store your observations. Once you have this data in structured storage in some data warehouse, you can start using machine learning to support testing.
And is it possible to connect to do this type of testing without any connectivity available based on the data that is currently available? Or do you need the constant connection with the system?
As soon as you have data, it is possible to do something with the data. In our testing practice, we often try to separate data generation before execution, then producing data during test execution, and separate data processing after test execution. This is a good idea because it allows us to reinterpret output data set several times. So if our first interpretation of large volumes of collected data is not correct, we can change interpretation scripts and obtain better understanding of the same data. And it means that, yes, it should be possible to separate test execution and offline test evaluation and test output evaluation. Of course, there are many compliance, regulatory and technical limitations. Some scenarios and some test libraries can result in volumes of data that is difficult to transfer from one location into another. In some compliance environments, it is not possible to transfer data from one location to a set of other locations. So these are all questions that we have to take into consideration.
Yeah, but basically you will need an extra fresh data at some point anyway, because you will use
Sure, because
data.
AI-enabled systems constantly change. So if we obtain some insight on the current state of the system, it is very likely that based on the new data, the behavior of the system will change, and we will need to reobtain data and run more cycles of evaluation.
Yes, thank you, Iosif. The Center of Excellence that you've been describing, you based on the example of the trading system, meaning the complex systems. I understand that is it possible to apply this approach of AI Testing Center of Excellence for any other domain apart from financial one?
Yes, it is, of course, possible to apply the same approach to any other important domain where it is possible to collect lots of data and try to use it to support testing, or where the systems that are present can be interacted with in order to explore lots of scenarios. So it is industry agnostic. The question is whether it can be applied for less complex systems, so whether it is justified to use something like that for simple systems. There are already lots of AI agents that go through simple websites and trying to crawl the data and generate scenarios using simple methods, and then try to process this data to obtain some insights about the software. It is a slightly different area of work than what we do. So most of the systems that we have to deal with, they do contain lots of specifics. So many websites are similar, many backend systems are different. But core ideas that are present in AI testing course, they are of course applicable to both complex and simple systems.
Yeah, thank you for the response. So I'm looking through the through the chat, and I don't see any other questions sent to me. Thank you very much, everyone, for listening to us and staying with us extra time. I think we can wrap up. Iosif, thank you very much, Iosif, for the presentation, and I think that the sources and links that you shared were very useful, and we'll come back to that. Stay tuned, everyone, for the updates and follow our LinkedIn, X, and YouTube channel, as Iosif mentioned. And I wish all the best, all of you, and see you all on our next Exactpro webinars. Thank you.